another stereo this time to work on. This time we've got one that has extremely distorted sound. Well, it had distorted sound on both channels, and then one channel cleared up, but the right channel remains extremely distorted. And we're going to have to do a little bit of investigating on this one to find out where the problem is. It took a while to find it, but in the end, we got this one working. Let's check it out. Oh yeah, this one has a problem. Let's get the top off this one. Severe distortion is the complaint on this one. Here's the guts of this one. Power amplifier board is right there. What we need to determine is the problem in the power amp or is the problem in the preamp. So we're going to isolate, see where the fault is. Now this unit only has a preamp output for the center channel. If I put it in Dolby 3-channel logic and put it on my existing amplifier, we can hear that the sound is clear. If I turn the speakers on, okay, now it's sounding good. Out of one speaker. Wasn't that interesting? It was all distorted. The right channel is distorted now, the left channel is clear. So in direct mode, the left channel is clear. The right channel is not. Turn off the direct so I can use the balance control. I hear noise on the left channel as well. Hear the static without any volume. We definitely have a problem in the amplifier over here somewhere. Let's just see if we can isolate that by giving it a little bit of a tap. Let's see if we can make some noise. Is it a loose connection? Probably have to drag out the scope and look at the signal going in and see if the signal going in is clean. So let's drag out the scope on this one. Okay, this is the left channel, this is the right channel on this board. This is probably the center channel over here, and the surround transistors are probably below on one of these boards. See, that's the noise on the left channel. The left channel actually will produce sound. And you can see all that noise. The right channel, if I go to the right channel, this is all I get. Let's take a look at the input. All right, if I look at the input, this is the input connector from the volume control. And the right input is this one right there. If I crank it up, Well, the signal's clean. I'll show you the scope. Problems on this board here for sure. I'll show you the scope. See, that's the volume. That's the right channel. Left channel, nothing there. Right channel. So the signal is clean going to the power amp board. So that means our problem is on this board. So I'm just going to power it down, and I will remove the board. We can we'll give it a visual inspection first, see if there's any connections that are cracked on here, because certainly cracked connections will certainly create problems. These boards are not easy to work on because you have to take out all the transistor mounting to lift the board out. It's secured down to the heatsink. Transistors are mounted on the foil side, as you can see. So it's another dumb design by Pioneer, you know. But at least I should be able to remove this block and loosen off all the screws and remove the board so that I can inspect it. Okay, 4 screws on the back out, 2 screws down here. The block will unplug or will lift out from the main board, and at least on this one they gave us wires that were reasonably long enough to pull the unit out to give it a good inspection. I say I gotta remove the transistors, the tops of the transistors here, just so I can swing the board out. And is there any other screws? I think there might be another. No, just plastic clips. So once I remove the screws holding down the transistors, then I'll be able to lift the board out, separate the board, and we can give it a good visual inspection. Oh, those screws aren't very tight. Like, that one's a little tighter. The left channel was also not working, and then it kicked in, but it kicked out again and then kicked back. While it's making that crackling sound, it was clean, but as soon as the crackling sound went away, it became very distorted again until it cleared up and then started doing the crackling noise again. This one's using 4 output transistors per phase, so get your PNP transistors and your NPN transistors, left channel, right channel. Yes, that's the way it came out. I'm going to check this for connections. I see all kinds of really flaky looking connections in here. Right down here on this transistor, for example, it doesn't look like it's even soldered right there. I'm just going to take a close look at this board and see whether it's just bad connections, because it sure looks atrocious, some of these joints here. And that's certainly what it sounds like. Either that or a transistor is bad, but just the way the one channel cut in like that generally indicates that it's either a voltage missing or a connection that's bad. And looking at this board, yikes. How about our big power resistors here? How are they? These are the emitter followers. I'm going to go over this board. Do you see what I mean, right? See the cracks? That one's not even connected. This is likely where our fault is. So I'm just going to basically go over this whole board. I don't know that I need to film the whole process. I'll be here for a bit on this one, but I'm gonna basically go over everything that looks like it could be causing the fault. And I see lots. Looking with my magnifiers on here, I see lots that are very questionable. This one right up here, you guys can see it on camera or not, but that looks questionable there. Some more over here. Anyway, let's I'll just leave the camera running for a bit as I get into this. We're going to resolder that whole board. both sides because the left side was acting up too, and then try it again. And I probably should look at the other board. I don't think he uses this for surround though. I'll ask him if he's just using it for stereo sound. Then if their other channels aren't being used, then there may not be any point in spending extra time and money on it, because generally people that use these old things for listening to music don't want to spend much in the way of money. Looks like somebody's already gone over the other channel. There's some connections that look like they were touched up at some point, so this may have been serviced before. Of course, I'm referring to these ones in here. These look like they've been done. This one here's cracked. I may be able to power this up without putting the board in just for a few seconds to see whether I've got it. Obviously it'll overheat pretty quick without the heat sink, so I'll only be able to leave it on for a few seconds, but that should be enough so that I can hear it's working, hear if I've made any improvement before throwing it all back together. These connections here look like they've been redone. There's all kinds of flex and stuff around them from someone working on this one in the past.
Pioneer's junk.
So a transistor, the leads are so close together, it's like they're almost touching, so I'm just going to put a bit of separation. This is a thermal compensator transistor, and leads look like they were almost touching. They possibly were touching. This transistor doesn't look like it's soldered down at all. Okay, I want you guys to listen to something. I've got it turned on. I'm just going to put my finger down here in this bias area. Right in this area. Maybe a resistor that's gone open. Right in this area here is where I've localized this to. What do we got down in this area? Oh, there's a transistor down here and there's a couple of resistors. Let's just check. It could be this transistor here. Let's just check some of these resistors and see if any of these resistors. This is in the right side driver stage. So maybe a resistor here has gone out of spec, or one of these transistors may be bad. This is definitely the area that we're working on. Let's see if I can localize it just a little closer by just putting my finger on there again. Right on Q206, right? And across C208. Now it's just skin resistance that's bringing that transistor online. So I'll measure some voltage just while I'm at it. So this is the transistor here, Q206. I've got 75 volts on here on one side, 0.5 on the other, and this side here has got 72. Now when I tickle this, what does the voltage change to? Does it change? $74 volts.
Yes, this is a wet finger test. I am sticking a wet finger into 70 volts, but no, I don't feel a thing.
It does drop. Right now this is at minus 1.2, and when I touch it, it goes up to plus. So I'm bringing this transistor into conduction ever so slightly. So this transistor is out of conduction. So it might be one of these resistors down there. Let me just check the voltage here. What do we got? 74 volts, 74 volts, 74 volts, 72 volts, minus 0.8, minus 0.8, minus 0.8, 74, 0. This is the one that changes. This is the one that comes up to like plus point. It's at minus 0.75. This one comes up to like plus 0.2 when it comes on. Where is it fed from? It's fed from over here, minus 0.5. Now back to this bias, back to this transistor that kind of looked like it was shorted or touching. This is the thermal compensator, but it's at minus 0.6 volts as well with the bias control. Minus 0.6, minus 0.6, that looks normal. Now the left channel is doing its dance again. voltage going in. 12 volts, minus 12. Gonna dig up a schematic for this one, and we'll take a look at the circuit and how it operates. It's definitely something in this around where this Q206 is. This is right in this area. When I touch this area, I'm bringing this transistor online. So we've lost a bias. One of our bias voltages is a little bit low. More than likely, it's going to be a resistor, or still it could be a connection, but it could be a resistor that's open as well. Alright, so here's the schematic. This is the transistor here that I put my finger on and it starts to work. And if we look at what supplies this transistor, it's driven off of our Q202. There's a couple of resistors in there. I've already checked a few of these. They're okay. I'm looking at this one here. This is the 5.6K resistor R234. Let's see what this one measures. R234 is measuring, if I can find it here on the board, it's this one right here. R234 is measuring 37K. Where is it? $37K, R234, showing us 5.4K. Let's just take that one out and measure it. Out of the circuit, it's fine. So it's not that one, so let's just look a little deeper. I think there's a connection problem still on this transistor. This is the bias, temperature compensation. Okay, let's try it again. Oops, knocked up my light there. Power. Okay, right channel. Remember all just started? Left channel. Right channel. Alright. So here there was a cracked connection on middle lead, whatever one that is. I think it's collector on this one. Anyway, so this one here, remember when I touched my finger, my wet finger, across the capacitor here, and I applied a little bit of bias on this transistor and everything came back to normal? Well, that's because this transistor here was not providing, it was not going into conduction. This is the bias control here. This is the thermal compensation. So as it's mounted to the heatsink. So as it gets hotter and hotter, the conduction of this transistor will go up just because of heat conduction, right? It acts like a thermistor basically. Connection cracked here, no voltage or incorrect voltage here, over here to this collector of this transistor. This is what basically pulls it down. That otherwise just runs up to the full rail voltage. Anyway, that was cracked. I'm going to take a look at the other one for the other channel, the other side. Just make double sure that it's that one's good, and then start putting this one back together. So there's the transistor for the other side. As you can see, I'm just going to make sure that it's good. What I did is I just brought the trace out a little more. It must have been cracked right at the junction here. So I'm just going to make sure that this one's good. Where it was cracked, right there, right on the circuit board.
just as I did on this one. Right there. That's where I brought it out to here. Must have been cracked right on that base there, right on that connection. It was cracked. And that was what was causing the problem on this one. Now if I power it up again before throwing it together, just to make sure everything is good and that I have both channels. Right channel, left channel. There we go, it's all back together. We got one of these that's acting up. Check that main board for connections, especially on that temperature compensation transistor. Thanks for watching. We'll catch you in the next one. Bye.